Hello students, in this video we learn about laws of exponents for real number. So what are exponents? Exponents are also called as powers or indices. Let us have a look. We've got over here 7 square. In this 7 is known as the base and 2 is known as its exponent, index or power. Plural is indices. Okay. The exponent of a number tells us how many times to use that number in a multiplication. For example, the example that is given over here is 7 square, which means that it is 2 times 7 repeated, which is equal to 49 in this case. So powers tell us how many times a number has to be used. Okay, that is the base. In this case the base is 7. Okay, now so how does it help us? Now this was just 7 raised to the power 2. What if we have 8 raised to the power 10? In this case we would have to write 10 times 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when we write something like this, okay, in the exponential form, it saves us the trouble of writing 8 so many times. It is understandable that 8 raised to the power 10 means 10 times 8 is repeated. So that is why we use exponent, okay, and it helps us in a lot of problems that we will see in the next video. For now we concentrate on the laws of exponents. See what are the laws of exponents for real numbers. So this says let a be greater than 0 be a real number and m and n are rational numbers, then a raised to m into a raised to n will give us a raised to m plus n. So that is our first law. What is the basis of this law? That a should be greater than 0. It should be a real number, so it cannot be an imaginary number. Secondly, m and n, the powers or the exponents, okay, should be rational numbers, so they cannot be irrational. In this case, when a is raised to the power of m multiplies with the same base but with a different power, then it is equal to a raised to m plus n. So the powers get added when the bases are multiplied. So if we take an example in this case, let us see what will be the example. Let's say 2 raised to 1 into 2 raised to 2. Look over here, the bases are the same but the powers are different. Okay, then this can be written as 2 raised to 1 plus 2, which can be written as 2 raised to 3. Understood? So here the powers get added only if the bases are the same and they should be multiplied. That is, the bases should be multiplied. Okay, let's move to the next law. Next law says a raised to m upon a raised to n is equal to a raised to m minus n. So in this case, once again, the bases are the same but the powers are different, and here but the bases are divided, unlike here where the bases were multiplied. So when the bases get divided, the powers get subtracted. So in this case, if we take the same example, 2 raised to 2 into 2 raised to 1, sorry, not multiplied, it's divided. So 2 raised to 2 upon 2 raised to 1, this will give us 2 raised to 2 minus 1, which is equal to 2 raised to 1. Got it? So here the powers get subtracted. So it undergoes subtraction operation if the bases are divided, but provided the bases are the same. Move to the next. The next law says a raised to m, whole thing in the bracket, raised to the power n is equal to a raised to m into n. So if we have a base which is raised, which has a power, and that entire term is raised to another power, then the two powers of the base get multiplied. M gets multiplied with n. So if we take an example in this case, then it will look something like this. So 2 raised to 1, whole thing raised to 2, and in this case it will become 2 raised to 1 into 2, that becomes 2 raised to 2. So the powers get multiplied in this case. Next, okay, in this one there are two bases, a and b. Okay, and similarly b should not be equal to 0, it should be greater than 0. But though there are different bases, the powers are the same. Okay, and the two bases have been multiplied with each other. So in this case what happens is the product of the two bases share a common power. So it is put in brackets and the whole thing is raised to the same power. So if we take an example, it will look something like this. 2 raised to 1 into 3 raised to 1. So the base is different over here, the two bases are different, powers remain the same. So this can be written as 2 into 3, whole thing raised to 1. So since the power is the same, the whole thing can be taken into a bracket and raised to 1. Similarly, we have a raised to m upon b raised to m, which is equal to a upon b, whole thing raised to m. So similarly, just like in this problem, here there is a division, and since there is a division, we continue with the division, but since the powers are the same, we put the entire bracket or the entire fraction, whole thing raised to the common power, which is m. So we'll take this example here. 2 raised to 1 upon 3 raised to 1. This can be written as 2 upon 3 raised to 1. So this is in case of division. So these are the 5 laws of exponent for real numbers that we need to remember. Okay, in the first 3 examples we have one base, the bases are same but the powers are different, and we have addition, subtraction and multiplication problems as well as division problems. Yes, and in case of the last two, they are with different bases. Okay, so when the bases get multiplied with the same power, then you can club them together under one bracket and raise them to the common power. Same thing goes with the division problem, where the bases are different but the powers are same, so you can put both the bases in one bracket and raise them to the common power. Okay, apart from these 5 laws, there are few more things that we need to remember, as they will come when we solve certain problem. Remember, any base raised to the power 0 will be equal to 1. For example, if we take 2 raised to 0, it will be equal to 1, or 100 raised to 0, that also will be equal to 1. So remember, any base raised to 0 gives us 1. Now any base raised to the power 1 gives the base back itself. So 100 raised to 1 will give us 100. Okay, and in this case any base raised to a negative power of 1 will give us a fraction. So in this case, if we take 2 raised to minus 1, that will give us 1 upon 2. So basically it is 1 upon 2 raised to 1, where the power becomes positive. This power becomes positive. So if the base is raised to any rational number n, then it will become a fraction where the base will be raised to a positive of that rational number, the power. So in case if this is 2 raised to minus 16, and then where n is equal to minus 16. So in this case what will happen is this can be written as 1 upon 2 raised to 16. You see the power becomes positive, but you have to put it into the denominator. This power, because it is negative, if it was positive it would have remained the same, but because it is negative we have to take it into the denominator, where in the denominator the power becomes positive, and then we can proceed further with the problem or solution. Got it? Now let's move to solving some problems in the next videos. Thank you for watching.